Hello student. Today we are dealing with the Poynting theorem and Poynting vector. This is our last topic of module 5. So for going through this, what is the vector or what is this Poynting theorem is, we have considered a closed surface. So I have considered here a closed surface S which is contain a volume V, and inside that, a charge is uniformly distributed, so the charge density is rho and the current density is J. And this surface having some electric and magnetic field. So this thing I have written here, that let us suppose that a closed surface S encloses a volume V having a uniform charge distribution Q, charge density rho and current density J. I forget to write here current density J, and surrounded by a magnetic and an electric field B and E. Now, how much energy is pumped inside this surface, or how much energy is come inside this surface or going outside this surface, it is only known by the interaction of field with the charge and current. Okay. Now, the magnetic field doesn't do any work on this charge. Why? Because as we know that when magnetic fields apply a force on a charge, that force is perpendicular to the velocity, and when we are going to calculate the power or rate of work, then it becomes zero. How it becomes zero? Because we know that power is equal to work upon time. And what is work? Work is force multiplied by the displacement. So displacement upon time becomes velocity, and because the velocity and force in the condition of magnetic field is perpendicular to each other, therefore their dot product becomes zero. So in such a situation, the magnetic field doesn't do any work on a charge. Only electric field do the work on a charge. That's why the total power, or we can say that the energy rate, is equal to what? The energy rate is equal to the volume integration of E dot J dV. Now from where we get this E dot J? So as we know that force is equal to the electric field multiplied by the rho. What is rho here? It is a charge density. So electric field multiplied by the charge density, and as we know that power is equal to velocity multiplied by force. So if you are going to be put the value of force here in the terms of E and rho, then the rho multiplied by velocity is become J. You all of you know that drift velocity, by the derivation of drift velocity, that E dot J. So V multiplied by rho becomes J. So our power becomes E dot J. So what is our rate of work? Or we can say that power, uh, which is pumped inside or outside inside this field or on the charge, is equal to the volume integration of E dot J dV. Okay. Now, by using the Maxwell's fourth equation, or we can say that we know the Maxwell's fourth equation. What is the Maxwell fourth equation? Del cross B is equal to mu naught times of J plus epsilon times of del E by del T. So, with the help of this equation, I am going to find out the value of J. So, what is the value of J now? Take mu naught here and take this epsilon naught d by dt this side. So what my equations become, J is equal to 1 upon epsilon on naught del cross B minus mu naught 1 upon mu naught del cross B minus epsilon naught del E by del T. So this is my equation number 2. Now I'm going to substitute the value. I am going to substitute the value of J from equation number 2 to equation number 1. So my equation becomes like that. My rate of work is becomes like that. Now as you see here that there is a one thing, uh, that is the e. So I'm going to multiply this e inside this two equation. When I multiply this two, oh, what my equations become? So as I multiply e in the both terms, what I get? I get this equation. Now I know I am not going to change this equation because it is equal to as it is. I am putting it as it is. But when I put this e inside this, when I multiply this e inside this, then this equations become what? This equations become e dot del e by del t. Or we can write down this equation by del e by del t 1 upon on 2. I forget one thing. I forget here to write down the 1 by 2. So one thing is also coming here, and that is the 1 over 2. Okay, so this is my equation now. Now what is my equation? And if I recalculate this equation, then I will get this again. Okay, so e dot del e by del t can be written like that. And what is actually this? Actually this is the energy store inside the uh, energy store inside here. Also I forget to write down, this is the energy which I store, which is stored inside the electric uh, field. This thing you have already wrote in your 12th class, that this 1 upon 2 epsilon naught del e square, it is the energy which is stored inside the electric field. Okay, yeah, whenever we are applying an electric field on any charge, then this energy is stored inside the electric field. I omit the del upon del t because it is also, it is represent just a power, or we can say the rate of change with time. Okay, so this is the energy which is stored inside the inside due to the electric field, or the store electric energy. Okay, now I am going to solve this term. Okay, now I'm going to solve this term. So for solving this term, I'm using a vector identity. Del dot e cross b is equal to b dot del cross e minus e dot del cross b. So with the help of this identity, I take out the value of e dot b cross e, because this is my, this I need the value of this equation only. So e dot del cross b becomes what? B dot del del B dot del cross E, and we take this term this side, so it's minus del dot E cross B. Now I'm going to substitute the value of E, this value here in equation number 3. Okay, so my equation becomes like that, that 1 upon mu naught b e b del cross e, b del cross e minus del e cross b dv minus 1 upon, I forget to put 1 by 2 here, so you have to also write down u1 by 2. So 1 by 2 epsilon naught e square by dv. This is my equation number 3. Now I have seen one thing here, that del cross e, and I know that the value of del cross e from the Maxwell's third equation. And what is the value of del cross e? Well, third equation is, you know very well, it is what? It is the minus del b dot del minus del b by del t. So I'm going to substitute this value in our equation. So what I will get, at the place of del cross e, I have written what? Minus del b by del t from Maxwell third equation. Okay, so my equation becomes like that. Now see again, if I am going to write this equation again, in which form? In this form. Okay, so I am taking b inside, so b multiply b becomes b square, and again I forget to put here 1 by 2. Okay, and this, what is this? If I am taking it like that, if I am going to open this bracket and write the equation like that, then again I found void, again I found this, and what is this now? Now, this is again, and we can omit the del by del t. So again, what this equations become? This equation is show the stored energy by magnetic field, or we can say that the energy stored in a magnetic field or due to the magnetic field inside that surface S. So this energy is due to the electric field. It is here also I am putting 1 by 2. Here also I am putting 1 by 2. Don't forget this, students. And so this two terms. One is for the electric energy, store energy in that surface due to electric field. This is the magnetic energy which is store inside the field due to the magnetic field. So I take these two terms right hand from right hand side, from my right hand side to the left hand side. So my next term become what? 1 upon mu naught del dot delta dot E cross V dV is equal to minus d W by dt minus this whole term. Okay. So now see what this term is. Before doing this, I do one thing. I applying here this side. I am applying this side what Gauss theorem, and I am going to change the volume integration into the surface integral. Here I am changing what I am release the delta. Why? Because in we know that volume integration is changed by the surface integral by applying the Gauss divergence theorem. So delta is omit and volume integration omit and surface came here. So now see here what happened. This whole term is denoting the energy. How? See, this dw by dt is the mechanical energy, which is, yeah, the power, or which is coming through the work done over the charge, and this energy is coming by the electromagnetic energy, or we can say that these two terms, one term is store energy due to the electric field, another term represent the store energy due to the magnetic field, or we can combinedly we can say that this is the term which show the store energy due to the electromagnetic energy. So this term is represent the electromagnetic energy, this term represent the mechanical energy. It means that this whole term is also represent the energy. Okay. eh? So this term is known as what? This term is known as Poynting vector. This term is known as Poynting vector. So what is our, and it is denoted by S. So what is our Poynting vector? Poynting vector is E cross B upon mu naught, and it is also representation of energy. Now which type of energy it represent, and what type of energy and what it's represent, or we can say that what is the significance of this S. So what this shows, that this shows that the we have chosen a closed surface now. So in this closed surface is what happened, the energy, the work done is given by the mechanical forces, and due to that the energy is stored here, and we find out that we are getting the minus sign. It means that this, due to this work done and energy storage, the total energy flow inside the volume, and this flow of energy is represented by what? This flow of energy is represented by this E cross B E over mu naught. So this S is what? This S is nothing but it is a flow of energy. But flow of energy what? Per unit per unit uh, time, because we are using here time. So per unit time, if we take time here, then per unit time, per unit area, per unit time, per unit area. Do not confuse that, because sometime what happen ना, तुम लोग कंफ्यूज इस बात से हो जाते हो कि ds जो है यहाँ मल्टीप्लाई में लगा है, dt भी मस्त है, तो ये जो है वो कैसे हो गया पर यूनिट टाइम या पर यूनिट एरिया। सो डोंट फॉरगेट दैट कि जब आप यहाँ पर इसको ले रहे हो, इसको ds को यहाँ ले रहे हो, dt को यहाँ पर ले रहे हो, तो ये एक तरीके का पावर बता रहा है, ये भी एक तरीके की पावर है ना। तो ये एक्चुअल में जब इसको वर्क के रिस्पेक्ट में लेंगे तो ये पावर में से सरफेस नीचे आ जाएगा, टाइम भी इसका नीचे आ जाएगा। तो उस कंडीशन में यहाँ पर क्या हो जाएगा, अगर इसको हम वर्क के रेफरेंस में लिखना चाहें, यानी ई क्रॉस, अगर बी को मैं वर्क के रेफरेंस में लिखना चाहूंगी, ठीक है, ये बी क्रॉस है, ठीक है, अपॉन मेरे पास में नीचे अगर मान लो मैं म्यू जीरो अगर मैं यहाँ पर लगा लूं, तो इसको अगर मैं वर्क में देखूं तो ये एक्चुअल में क्या है, ये मेरे पास में एक पावर है, W बाय टी के फॉर्म में ही होगा ना, क्योंकि ये भी ये वर्क है, ठीक है। अगर अगर मैं यहाँ पर देखना चाहूँ तो ये पूरा का पूरा एक वर्क अपॉन टाइम है, तो यहाँ पर ds लिखा है, ठीक है, यहाँ पर अब क्या लिखा हुआ है आपका, ds लिखा है, तो ये ds भी आपका कहाँ आ जाएगा, नीचे आ जाएगा। सो ये एक तरीके से क्या हुआ, ये हुआ वर्क पर यूनिट टाइम पर यूनिट एरिया, यहाँ टाइम आएगा ना dw बाय है, यहाँ पर क्या आ जाएगा dw बाय dt, ठीक है। सो dw बाय dt है, अब ds को भी नीचे ले आएंगे, तो उस हिसाब से E क्रॉस B बाय म्यू क्या हो जाएगा, ये एक तरीके का वर्क हो जाएगा जो पर यूनिट टाइम में होगा और पर यूनिट एरिया में होगा। पर ये वर्क नहीं है, ये क्या है, E क्रॉस B है। E क्रॉस B क्या बता रहा है कि कितनी पावर इसके अंदर फ्लो हो रही है पर यूनिट टाइम पे और पर यूनिट एरिया पे। दैट्स वाई हम क्या बोलते हैं, हम ये बोलते हैं कि जो हमारा क्या होगा, पॉइंटिंग वेक्टर होगा, वो हमें क्या बताएगा, फ्लो ऑफ द एनर्जी। हमारा पॉइंटिंग वेक्टर हमें क्या बताएगा, फ्लो ऑफ द एनर्जी जी, पर यूनिट टाइम पर यूनिट एरिया। ओके, ये देखो बता रहा है फ्लो ऑफ एनर्जी पर यूनिट एरिया पर यूनिट टाइम। ओके, और इसकी डायरेक्शन क्या होगी, इसकी पर यूनिट टाइम पर एरिया एरिया पर यूनिट एरिया पर यूनिट टाइम, और इसकी डायरेक्शन क्या होगी, व्हाट इज द डायरेक्शन ऑफ एस, एस, the direction of s is always perpendicular to the direction of E cross B, means that it is in the whenever the direction of s is always along with the direction of propagation, and or we can say that it is always perpendicular to the E cross B. Okay, so today the Poynting theorem, and this theorem is known as a Poynting theorem, and s is known as a Poynting vector. This whole derivation is known as a Poynting theorem. So today our last topic is finished, and this module 5 is also finished. Thank you, students.